Can you hear me?
Yes, ma'am.
Thank you.
Good morning, ma'am.
So yesterday we were dealing with isotropy and anisotropy. Crystalline substances are anisotropic in means some physical properties like electrical resistance or refractive index when measured along different directions give different values in the case of crystalline solids. So we say crystalline solids are anisotropic in nature. Next we are going to see pseudo solids. Pseudo solids means false solids. False solids. For example, glass, when you look at the glass, it looks like a solid, but it is not a solid. It is a super cooled liquid. And it can flow also. It flows slowly, slowly downwards. You know, in old buildings, the glass attached to the window panes look thicker at the bottom and thinner at the top. That means glass flows slowly, making the bottom portion. Glass flows slowly, making the bottom portion. So glass is not a solid, but it is a super cooled. And some old glass pieces, you see, it becomes milky. When it was mixed, it was transparent. But now, when you look at these old glass pieces, like mirror pieces, broken mirror pieces, old ones, they look milky. This is because as on heating, the glass becomes crystalline. So some crystallization here and there it takes place. That's why the glasses what we get from ancient civilization, uh, they are found milky due to some crystallization. So on heating glass, some portions and some portions crystallization takes place. That is how glass from ancient civilization look milky. That's about crystalline and amorphous. Next, we are going to classify crystalline solids. Crystalline solids are classified into different categories: molecular solids, ionic solids, metallic solids, and covalent. Classification of crystalline solids are classified into different categories. one is molecular solid, then ionic solid, then metallic solid, and cold. Molecular solids means the constant particles are molecules. Ionic solid means constant particles are ions. Metallic solid, constant particles are atoms, but atoms after the releasing of electron. Such type of atoms means they can release electron very easily. After releasing that electron, atom is not a whole atom, then it is positively charged ion. Positively charged ion means cation and electrons. In polar solids, again atoms. Polar solids, the constant particles, those are atoms. In metallic solid, for example, sodium metal, positively charged ions and electrons. Positively charged ion and electron. Positively charged ion and electron. Ions and electrons. Ions means after the release of electron, that positive portion, that is cation. Cations and electrons. You can say ions and electrons. So metallic solids. So crystalline solids are classified into four categories: molecular solids, ionic solids, metallic solids, and covalent solids. Molecular solids, I told you molecules are the constant particles. For example, hydrogen solid. Normally when we say hydrogen, the gas, you can cool it to a liquid. Again you can cool and press. It becomes a solid. So you can make anything in this world into solid. Hydrogen solid, I2 solid, iodine solid, oxygen solid, nitrogen solid. You can make any gas in the form of solid. XII solid, hydrogen solid, then iodine solid. It's not easy to keep hydrogen solid. It should be kept under high pressure and at very low temperature. So, what are the characteristics of molecular solid? Molecular solid, the constant ions are molecules. There can be different types of force of attraction between the constant particles in a molecular solid. Will be saying that force of attraction in molecular solids. So molecular solids are again classified into different categories. That is non-polar molecular solids. Non-polar molecular solid, polar molecular solid, polar molecular solid, hydrogen bonded molecular solid, H molecular solid. Non-polar molecular solid means between the constant particles there is no force of attraction, or we can say only van der Waals force of attraction. Non-polar. H2 solid, here I2 solid. This is I2 solid. Between them, the force of attraction is only van der Waals force of attraction or London dispersion forces. Only the van der Waals force of attraction, or we can say dispersion forces or London dispersion forces, or simply London forces. That is the force of attraction existent between the partial particles of non-polar molecular solid. In the case of polar molecular solid, for example, HCl. HCl itself is a polar molecule. So here negative, and here delta negative, and here delta positive. So here delta negative and delta positive. It itself is a polar molecule. Between polar molecules, see, the The dipole. You consider another XII. This is XII. You consider another XII. So delta negative, delta positive. Between this delta positive and delta negative, interaction is there, attractive forces are there. We call the attractive force as dipole-dipole interaction. So what is the force of interaction between the molecules of polar molecular solid? This is XC, this is XC. Or this is SO2, that this is SO2. SO2 solid, HCl solid. So this force of interaction is called dipole-dipole interaction. One type and the second one is the second type. So the force of interaction between the particles of polar molecular solid, there is dipole-dipole interaction. What about hydrogen bonded solid? Hydrogen bonded solids, for example, ice or HF solid. These are hydrogen bonded solid. Ice, H2O solid, that is ice. H2O solid or HF solid or NH3 solid. All are in the solid format only you have to consider because the chapter deals with solid state. Whatever I am telling that in the solid format. NH3 solid, we know that hydrogen bonds are existing between H2 molecule. Similarly, HF, that is solid. The force of attraction between HF molecules in the solid form of HF, that is hydrogen. NH3 solids, again, hydrogen bonding is existing between molecules of NH3 in the case of NH3. So that's about molecular solids. What about ionic solids? Ionic solids, sodium chloride, NaCl. In the case of sodium chloride, so many Na plus Cl minus, Na plus Cl minus, Na plus Cl minus, Na plus Cl minus. So many Na plus. They are in contact with Cl minus. Similarly, Cl minus in contact with Na plus. The force of attraction between the constant particles, that is ionic bonding or electrostatic force of attraction. Attraction between positive and negative, we call it as electrostatic force of attraction or ionic bonding. So the force of attraction between the particles of ionic solid, that is ionic bonding. Now, what about its melting point? In the case of molecular solids, melting point is low because the force of attraction is not that much. Only in the case of hydrogen bonding, there is a better force of attraction. So there, H2O will be having higher melting point. So here, in this case, we will be talking about melting point because all are solids. Whether it is molecular solid, ionic solid, metallic solid, or covalent solid. In all cases, we will be talking about melting point, whether the melting point is higher or lower. Where there is hydrogen bonding, there is high melting point. Now, what about this melting point? NaCl melting point is very high, about 1350. So, due to the high force of attraction, 1350 degrees Celsius, that means ionic solids, due to the strong force of attraction between positive and negative ions, means Na plus and Cl minus. Due to the strong force of attraction between these ions, their melting point is very high. Melting point is very good. Now, in solid state, in the solid format, this Na plus and Cl minus cannot carry electricity. That means in solid format, NaCl cannot conduct electricity. But in the molten state, ions are little far apart. There is mobility, they can carry current. And also in the dissolved condition, when it is dissolved in water, these ions are very much free to move. So in the dissolved condition, means in aqueous solution, they can conduct electricity. They are the carriers of charges. In the case of molten state also, it can conduct electricity. But in the form of solid state, in solid format, NaCl or ionic solids cannot conduct electricity. What about metallic solids? Metallic solids, in the solid, electrons are free to move. Electrons of the charge carriers are there. So, metals can conduct electricity. Metals can conduct electricity. So, what is the special feature of metallic solid? Conductivity even in solid state. But in solid state, ionic solids cannot conduct While metallic solids, even in solid state, they are good conductors. Melting point, of course, melting point is greater, not that much greater as compared to this ionic solids. Here 600, 900 like that, but it goes about 1000, 1500, 1600, but here 900, 600 like that. That varies from metal to metal, this boiling points, melting points. What about covalent solids? In covalent solids, for example, diamond. So the bonding is covalent, but due to their structure, they have strong lattice, strong crystal lattice. So these two metals are very strong, like diamond. But diamond atoms in covalent solids, atoms are the constant particle. These atoms are connected through covalent bonding, but in the tetrahedral way, or due to their structure, they have got very high melting point, like 4000 degrees Celsius, 3000, 3000. Diamond has melting points 4550. So their melting points are varied in this range. Covalent bonds are the most attraction together. There are covalent bonds between atoms, and these atoms are connected through tetrahedral way or through trigonal planar way. In the case of diamond, it is tetrahedral. In the case of graphite, it is planar. It is in the planar format. In graphite, there are layers. Due to this planar format, there are one plane, second plane, third plane, like there are planes which can, between the planes, only one of those source of interaction is there. In the case of diamond, carbon, carbon, carbon. So let us suppose so many carbon atoms are joined by covalent bonds. Strong crystal it is. Diamond has got a strong crystal. Melting points are very high. But in the case of graphite, due to the structure, this is one sheet. Like this one sheet. And between the next sheet, there is only van der Waals force. The second sheet, between the first sheet and second sheet, this is one layer, this is one layer. Between these sheets or between these layers, only how much force of attraction is existing. So when you write with a pencil, you are actually moving, you are shifting or you are moving this layer by layer on your paper. So you see the mark on the paper. While writing, you are breaking this one force of attraction. While writing, you are breaking this one force of attraction, and these layers are made to come on this paper. That is how you get a mark, a nishan on that paper. That is how we are able to write using graphite leads. Graphite leads, what you see, not lead, it is lead. Graphite lead, which is present inside the interior center of this pencil. So that's a classification of crystalline solids. And here, graphite is a conductor. Generally, covalent solids are non-conductors, but graphite is a conductor because due to sp2 hybridization, each carbon has got one unpaired electron. This electron is responsible for each and every carbon. There is one free electron. So many free electrons are there in the crystal, so they are responsible for carrying the current. So electrons are the charge carriers. This does not show any conductivity. This shows conductivity in aqueous state and also in molten condition. This shows conductivity in the solid format, even in the solid format. Polyocytes generally do not show conductivity, but graphite can show conductivity due to the presence of unpaired electrons present on each and every atom. Next, we are going to the details of crystalline solids. Crystalline solids. Their structure. The big piece is called a crystal lattice. So in this crystal lattice, so many small tubes can see. For example, I am showing this one. This is the big crystal lattice, and this is a unit cell. The three-dimensional arrangement of points in space is called crystal lattice. A three-dimensional arrangement of points in space is called this big crystal lattice. And this is the unit cell. Unit cell is the portion of the crystal lattice which, when repeated in different directions, generate this entire crystal lattice. So unit cell is the portion of the crystal lattice. The bigger one is called crystal lattice, and the smaller portion is called the unit cell. What is crystal lattice? A three-dimensional arrangement of points. A three-dimensional arrangement of points in space is called crystal lattice. Each point is called a lattice point. And this lattice point, you can see one atom or one particle or one molecule or one ion. That point is called a lattice point. Lattice point, lattice point, lattice point, lattice point, like that. And this is the unit cell. What is unit cell? Define unit cell. Unit cell is the portion of the crystal lattice which, when repeated in different directions, generates this entire crystal. Unit cells are of two types, primitive and centered. Primitive means, I'm taking only that unit cell. I have taken only the unit cell. This unit cell, if the atoms are in this unit cell, if atoms are present only at the corners, then we call it as primitive. When the atoms are present only at the corners, 8 corners are there, front 4 corners, back 4 corners. These 8 corners So this is primitive. But in addition to these corners, if there are atoms in the interior center inside, then we call it a center, or on the face center, like this face center, top face center, bottom face center, this side face center, back face center, like that. If atoms are present at the center, maybe at the body center, at the interior, or at the face center, such unit cells are called centered unit cells. So unit cells are of two types, primitive and centered. In primitive, only at the corners you can find atoms or molecules of particles, ions, whatever it is. The constant particles you can see at the corners, but at the center, if there are atoms, are at the centers also. When is in addition to this corner atoms, in addition to this corner particles, if you find the atoms or the particles at the center of the body or centers of the face, then we call it as centered unit cells. So they are of two types, primitive and centered. Thank you.